Okay, hello everybody. I'm Luis Pessoa, and we're here having a joint session today with the Neuroscience and Philosophy Salon and the Computational Phenomenology Fridays, which is a way cooler name for the session. Specifically Fridays, right? Computational Phenomenology Fridays. And so what are we going to do today is hopefully have a very lively discussion on how the free energy principle can inform our understanding of consciousness. And today, we are very excited, just make sure that I'm admitting everyone here. We're very excited to have Maxwell Ramstead and several, as I understand it, several people in the group that there's quite a few people in the author list of the paper that Maxwell is spearheading with others. And so Maxwell is currently the director of research at the Versus Research Lab, where he and his team are developing a new standardized approach to contextual computing, knowledge graphs, and graphical inference agents. Maxwell is also an honorary fellow of the Wellcome Center for Human Neuroimaging at UCL in the UK, where he works with Karl Friston within the theoretical neurobiology unit. Maxwell's research focuses on the free energy principle, as we all know very well from Twitter, Bayesian mechanics, multi-scale formulations of active inference, and computational phenomenology. So we're really excited to have you here, Maxwell. Versus is located where in the world, or is it?
We're an international. We're based in California, around Los Angeles, but we also have headquarters in Toronto in Canada and in Eindhoven in the Netherlands. Yeah, but mainly out of California.
And so your time zone is California time zone.
Currently, I am in Montreal, Canada.
Okay. So currently you are another time zone. Okay.
That's right, East Coast.
All right. Okay, great. So yeah, let's get started. You want to?
Excellent. Yeah, absolutely.
Take it away.
Well, thanks first of all for the invitation. It's really great to see all of you here, and I'm very excited to have this conversation. I'm looking forward to the discussion in particular. Yes, this is a joint session. We hold an international discussion group. It's basically weekly, on a weekly cadence on Fridays, the Computational Phenomenology Fridays discussion group. It's an open group, so those of you who are interested, please send me an email or a DM on Twitter, and I'll be delighted to add you. So today, I'm going to present some work on consciousness. The title of my talk is also the title of the paper, The Inner Screen Model of Consciousness. And so some aims and context. What we're presenting is work that was mainly done in late 2020, early 2023. The co-authors of the paper are listed right here: Mao, Adam, Alex, Brennan, Chris, and Karl. We've been working on this for a bit, and yeah, we've had several really important discussions that led up to the development of this work with the wonderful people that are listed right here. And so this started off as one paper that turned into a behemoth that we then split off into what is now 3 papers. And the aim of this series of papers was to present a minimal unifying model of consciousness premised on the free energy principle. So I won't be talking too much about the mumness of the model that we're proposing today. So I'm going to focus today on what we presented in the paper that was assigned for the discussion, which is really the idea that we can actually develop a model of consciousness directly from applying the free energy principle to known physiology, neurophysiology. So I would like to suggest that there are 2 takeaways to the talk. The first is that a model of consciousness can be directly derived from the free energy principle. So I think there's been a lot of interesting discussion in the literature and online as to whether the FEP has anything distinctive to teach us about consciousness. There have been answers pro and contra from our group and from others, throughout the last, I guess, decade and a half, 2 decades. Here, I want to present an affirmative answer to that question. And I want to suggest that the FEP allows us to evince the nested holographic structure of consciousness, which sounds maybe a little wacky and a mouthful, but as I'll try to show this, this follows from a careful unpacking of the free energy principle, and it's a little less wacky than it might sound. So the paper originally was elephantine in a number of senses. First, in the sense that it was enormous and we actually had to split it into 3 papers to get it published anywhere. But also in the sense of the Sufi myth of the blind man and the elephant. What we're trying to show basically is that there is something like an underlying theory of consciousness that you can derive directly from the free energy principle that then helps us account for existing models of consciousness that are premised on things like active inference. This will be less of a focus on in this talk. The original paper's structure had basically the first paper and then a review of existing models of consciousness based on the free energy principle and a discussion. It was just unwieldy. But it's worth quickly talking about what mums are. So Vanya Visa proposed 3 years ago now, that consciousness studies is currently something like a scruffy or like a very theory-rich approach with lots of different theoretical approaches kind of competing. And he suggested that what consciousness studies needs currently, rather than an additional or a new model, is something like a minimal unifying model, which would specify only necessary properties of consciousness. So it doesn't entail some kind of strong sufficiency claim whereby we say that we're completely explaining every aspect of consciousness, but only certain aspects. Obviously, if it's minimal, it provides determinable descriptions that can be made more specific and then elaborated in models, for example, computational models that could be tested. And finally, it's minimal in the sense that it aims to integrate existing approaches. All existing theories are false in some ways, and what we're trying to do is to kind of find a structure that underwrites a lot of current approaches to consciousness that might be able to guide us moving forward. So I'm going to start with a little crash course on the free energy principle. I'll be presenting its classical formulation and then the quantum information theoretic extensions that have recently been worked out by Chris Fields and colleagues. The inner screen model is in some sense a consequence of the quantum information theoretic formulation. And so, it's useful to review those materials, and then I'll try to quickly get through the presentation of the model itself, and we can discuss. So first things first, crash course on the free energy principle. I'm sure some of you are not super familiar with the free energy principle. So like backing up all the way, I think it's useful to open with what I take to be a standard distinction in physics between dynamics, mechanics, and principles. So I take it that everyone here is familiar and even friendly to dynamical systems theory. When DST is applied in physics, we describe we call the formal description of a system's behavior dynamics. So you might think of, for example, Kepler's this description of the solar system as a kind of dynamics, meaning like here's a descriptive account of the way things look from a formal perspective. You move from dynamics to mechanics when you can produce the equations of motion that explain the way that the dynamics are generated, right? So the movement from, say, Kepler and Galileo to Newton is the move from a kind of dynamical descriptive approach to classical mechanics, which gives you basically equations of motion that explain why the formal description of the motion is the way that it is. A principle is something that explains the way that mechanics are governed. So basically you use principles to generate mechanical theories or equations in motion. So in classical mechanics, one of the core principles is the principle of least action, which you can think of basically as the claim that potential and kinetic energies are always balance themselves out, such that the real paths of a system are those that for which the action is stationary or minimized. So you can think of the free energy principle as another of those principles, but not one that doesn't lead to classical mechanics, but rather to Bayesian mechanics, which is something like a physics of probabilistic beliefs. And I think from a kind of conceptual point of view, the interesting thing about the free energy principle is that it connects the information entropy of the beliefs that systems have about their world to the thermodynamic entropy of the states that make up a system and that encode those beliefs. So the FEP is really about that hinge between information theory and thermodynamics. And there's reason to think that it's the canonical way of articulating those two sets of things. So everyone, I assume, has at least heard of Markov blankets by now, but they are really key to the classical formulation of the free energy principle. If you have a bunch of states that characterize a system, and by system, I mean like a wide agent environment system. So you're talking about like some ecological niche, which with a bunch of things running around and maybe replicating themselves and so on. The idea behind a Markov blanket is that you can basically define a system in terms of the relations of conditional dependence and independence that obtain in the dynamics. And a Markov blanket is a way of articulating the statistical or probabilistic boundary of a system. We usually specify the dynamics of the entire agent environment system using this formal construct called a generative model. And the generative model specifies the dependence relations that obtain in the dynamics or flow or time evolution of the system that you're considering. And so a few important things to point out here. What the Markov blankets capture are the dynamical dependencies, not necessarily the physical boundaries of the system. So that's, I think, an important distinction. And the Markov blanket itself is defined by a specific sparsity structure. So the idea here is that the blanket is defined in terms of sensory and active states, where sensory states cause the motion of internal states, but are not caused by internal states, and reciprocally, the external states are caused by, or their motion is caused by active states, but they do not cause active states to move in or return. So this kind of structure basically separates or disentangles to the bulk of the system behind a boundary in some sense. And what the free energy principle tells us formally is that if such a boundary exists, then we can think of states across the boundary as tracking each other in a specific sense, where tracking means to encode the parameters of a probabilistic belief about the external states. So those of you who are kind of not super friendly to the notion of neural representation will want to note that we're not talking about a direct kind of tracking relationship where individual states behind the blanket are tracking individual states outside the blanket. We're talking about something more nuanced, where literally what I embody is the parameters that determine the shape of a belief. And then what we're saying is that basically this whole probability density that is defined over external states comes to be parameterized by the states of my body, given that this blanket exists over time. Yeah, so that's the classical formulation. I just in the interest of time, I'll try to get through the whole presentation before taking questions. Although if anything is really unclear, perhaps you could raise your hand and I could try to answer clarification questions. So much for the classical formulation. The quantum information theoretic formulation of the free energy principle emerged more recently. The main difference between the two is that the classical free energy principle assumes a space-time background. And so we actually appeal to the space-time background to use timescale separation in particular to define our systems of interest, where we have nested systems of systems of systems. Obviously, in order to have nested systems, you need to have some notion of space-time to say, well, these systems are big and they contain within them smaller systems. They are composed of them. The quantum information theoretic formulation of the free energy principle is scale-free. So, rather than working in terms of Lagrangian mechanics, you're working in terms of Hamiltonians. And I won't get into too much technical detail here, but the basic idea is that, the Markov blanket in both formulations is just defined as the set of degrees of freedom that separate and couple two systems that are distinct. So the quantum information theoretic formulation says, well, you can think of those degrees of freedom as a kind of screen that separate the inside of a thing from what's outside. And then you can formalize the interactions between things as basically the bulk of either system reading and writing onto the screen. So there are some mathematical advantages to flipping to this formulation. In particular, you can do some cool stuff having to do with topological quantum neural networks. Again, I'm going to try to be as non-technical as possible. There are some formal advantages to modeling things in this way. One thing to point out is that I'm going to be talking about holographic structure here. There are two different senses of hologram that might be in play. So everyone has seen a Pokemon card, right? That kind of changes as you flip it around. These are constructed using a technique called holography, where you superimpose different images and basically you can recreate a complex image through this kind of superposition of images and their interference. This is not, at least, I'll come to back to this at the end of the talk. This isn't the sense that's going to be at stake in this chat. The sense of a holographic or hologram that is relevant here is in the sense of the holographic principle from physics. The holographic principle from physics says that a system can only contain as much observable information from the perspective of an outside observer as can be encoded on its boundary. And there are reasons from black hole physics that explain that. Basically, if some bulk collapsed into a black hole and contained more observable degrees of freedom than could be encoded onto its surface, it would violate the principle of unitarity or the conservation of classical information. And so those things are not allowable. The holographic principle has been important in physics, and it sort of underwrites the quantum information theoretic formulation. You can basically think of the Markov blanket as a kind of hologram that projects all of the observer relevant information about a system, like the system projects onto that boundary, and then the boundary interacts with us. So Chris Fields and company, Chris Fields, Jim Glazebrook, and Mike Levin, three folks for whom I have lots of respect and admiration, proposed a few years ago that, so if all of the classical information that you need to describe the dynamics of a system from the perspective of an observer lives on the boundary or on the Markov blanket, then there may be a sense in which living creatures use this fact to process information. So would it not be reasonable to think that some systems develop something like an internal blanket where all of the classical information that it needs to process would live? And in some sense, like if you, this is just like a traditional kind of computer architecture in some sense, right? You sort of need an internal memory register to, just not be completely reactive, but to like deploy information that you are privy to in order to generate adaptive loops of action. In particular, in this paper, minimal physicalism as a scale-free substrate for cognition and consciousness, Fields, Glazebrook, and Levin proposed prediction number 6, which is that internal awareness requires internal boundaries. And so what we started doing over the course of last year was to see how far we could take this hypothesis. And what I'm going to be suggesting now is that, since the FTP can be used to model things with boundaries, and since the brain is a thing with boundaries and that has internal boundaries, it should follow that we should be able to use the free energy principle to model the brain and its dynamics, and hopefully say something interesting about consciousness. So we know from neurophysiology that the brain has a sparse structure. Is it a small world architecture? Is it a center hub architecture? I think the questions are still open. Empirically, it seems to be more of the latter. But what we know for sure is that the brain has this sparse structure where you have these kind of laminar organization, which means that it isn't the case that everything connects to everything. There is a sparseness to the connection. And what I want to suggest is that you can model this structure as a set of nested boundaries or Markov blankets in the sense defined above. And so there's a great deal of work on understanding neuroanatomy in terms of successively nested Markov blankets. We can start from the neuron and identify the postsynaptic conductance with the internal states, postsynaptic voltage with the active states, presynaptic conductance with the external states, and the presynaptic voltage with the sensory states. Again, these are not, the Markov blanket defines the dynamical dependency structure of a dynamical system. These are not, doesn't have to coincide with the physical boundaries of the system that you are looking at, although in the case of the cell, for example, it might. So starting from the neuron, we can ascend. And this paper that I'm citing below, that Ines Ippolito and our colleagues we have written together, basically re-examines in detail the neuroanatomy of the brain in terms of successively higher scale Markov blankets, where individual canonical microcircuits have their own blanket, and then regions have their own blanket, and then brain networks have their own blanket. And so on. I can only discuss this briefly given the time constraints, but I'd refer you to the paper for a more extensive version of this argument. From the individual neuron, you can also descend downwards towards gated channels, synapses, dendrites, and back to the body of the cell itself. You can understand these things as sequentially nested Markov blanketed structures that preserve their own integrity over time at some scale, while also coupling to the environment in which they are embedded. So this is a figure from predictive coding papers. You'll see some version of this often, where we represent the cortical hierarchy, for instance, as successive layers of information processing, where what the descending connections carry predictions about what to sense next, and the ascending connections carry prediction errors, which measure the discrepancy between the prediction and the data that is at hand at any given moment. This is pretty standard in the literature. One of the moves that we did in the paper is to point out that you can think of these layers in terms of their dynamical connections to other layers as constituting a successive series of Markov blankets. Basically, this is our way of implementing the inner screen hypothesis. So you have this external Markov blanket of the organism. Its effect is to, on the one hand, generate overt actions, and on the other hand, basically collect sensory data. And actually, this is a slightly better representation of what we have in mind. So there is, you have your Markov blanketed system. The existence of a boundary means that internal states are tracking the structure of external states. And the idea here is that, the internal states themselves in the brain have this kind of structure of a nested hierarchy of blankets. there's a notion of contextual compute. Luis mentioned that we were a contextual compute company at Versus, and this is, I think, a core part of our theoretical approach, is that the brain is an organ of context. It embodies successive layers of context. Any given layer of the brain is providing context to subordinate layers and being contextualized by superordinate layers, such that you can understand this succession of screens in the brain as progressively coarse graining information that was encoded on the subordinate screen. So when we talk about a nested holographic structure, this is what we're talking about: screens of screens of screens of screens, or screens within screens within screens within screens. So the kind of key architectural feature that we exploit in this paper is that there are two layers of this stack that, if you'll allow me the expression, are write-only layers. Your sensory end can only write into the system. And if you imagine this hierarchy of information processing layers, the very top layers are not contextualized, are not further contextualized by any information. There's like an irreducible Markov blanket at the very top. And that blanket, since it doesn't receive any context from a superordinate layer, can in some sense only perceive itself vicariously by kind of inferring its consequences on the overall stack. So what we're basically suggesting is that using this model, you can think of two kinds of action. The overt actions that organisms deploy in the world, and covert actions where the system is acting on itself. An example of this is attentional processing, where hierarchically superordinate layers are engaging in a neuromodulation of subsequent layers and thereby acting on them. So we, in the paper, proposed that the traditional kind of corticocentric hierarchy, whereby the top of at the top of the hierarchy sits, default mode and these other kind of prefrontal networks, and at the bottom sit the sensory areas, is incomplete. The prefrontal cortex, as I'm sure everyone knows probably much better than me and than the audience of neuroscientists, the prefrontal cortex you can think of as the controller of subordinate brain regions, but the controller in turn has a controller, which you might identify with these kind of top of the brainstem, limbic so-called areas. We can discuss the adequacy of that terminology, but structures like the hippocampus that in turn inhibit the activity of prefrontal cortex. And the idea then is that we were able to explain a lot of these findings associating basically the existence of consciousness within a subject and the intact or damaged character of these delicate upper brain structures. This may not be just an accident. Mark Solms, for example, has documented a lot of studies suggesting that if you knock out, for example, the periaqueductal gray, it's lights out and consciousness kind of collapses. That may be because, and this is a hypothesis that we're hoping to test empirically over the next few years. It may be that you need this kind of write-only layer at the very top of the stack to exert its kind of neuromodulatory influence in order to get something like robust consciousness. So I suggested earlier that I'm not going to be too interested in the concept of holography, that we're talking about holograms in the sense of the holographic principle and not in terms of holography. There may be a sense in which this is not a bad metaphor. In particular, if it is the case that you can think of the brain as a series of nested screens that successively coarse grain each other, there may be reason to think that actually there is something like a hologram in the holography sense being generated by the brain, where you have these kind of interacting wave fronts of cortical structures doing their message passing. And Adam Safron at least has proposed the idea that through the kind of self-organization of harmonic modes in the brain, you might actually get something that's closer to a holography principle for the brain, as opposed to like a hologram theoretic principle for the brain. This is sort of a frontier right now for us. We're not sure if this is just like a cool metaphor idea, or if there's legs to this, something we might be able to discuss. To summarize, what we're saying is that consciousness is the property of systems with a special kind of Markov blanket. From a neuroscientific perspective, this would correspond to an irreducible Markov blanket, a kind of right-only layer at the top of the hierarchy. Obviously, well, maybe not obviously, but we think that the whole stack is necessary for robust consciousness, but that a structural feature of systems that have a more kind of more robust forms of intentionality and more like things like theory of mind, that you would need this kind of apex structure to kind of get these more robust effects. There are interesting connections to the work of Thomas Metzinger in terms of opacity and transparency. Metzinger basically classifies cognitive processes into the transparent and the opaque, where most cognitive processes are transparent and that they're not readily available to us as cognitive processes. Rather, they make things in the world or features of ourselves available for exteroception or introspection. What we are suggesting so opacity, contrary wise, is the idea that certain mental states make other mental states available for introspection. So for example, attentional states are about other cognitive states and make them salient. When you introspect, you make some states of yourself available to yourself, you make them opaque. And so we believe that it's not a coincidence that there is this layer at the very top of the hierarchy that is not contextualized by anything, and that in some sense can only write down and be about its activity being about other states in the brain. It's as if the information kind of flows up and then has to be routed back in this kind of folding structure. That was a perhaps too brief presentation of the ideas in the paper. Thank you to Luis for the kind invitation, and to everyone here who in many ways shaped the contents of the presentation.
Thanks, Maxwell. That was really, I think, perfect level and opening up for a lot of discussion now. Hopefully we can get into more of the details if people want to ask you about some of the technicalities or whatever level people want to dive into, because there's so much there that we can explore, I think. So there's a lot here that I would love to be participating a lot, but I'm going to be trying to take everyone's questions first. And if there's a little bit of time, I'll ask a couple of things too, because there's so much there. So I'll open to everyone. If you can raise use the raise hand functionality on Zoom, and like Kevin is doing now, please do so. And then I'll try to take you in order. If I get the order wrong, because for whatever reason, just wave at me and tell me that I should be letting you speak first. So Kevin, yeah, please go ahead.
Great. Thanks a million. Thanks, Maxwell, and nice to sort of see you in two dimensions.
Two dimensions.
Yeah. Really interesting stuff, and a great presentation. Was super clear, which I really appreciate. And I have to say, this slide that you're on here, just makes complete sense. That's the way I think a lot of people think about the brain, as these sort of different levels that have some coarse graining between them, which means that in effect they're kind of black boxes, right? They don't know what's going on inside. They only get some signal or some some pattern that emerges communicatively from them, and you guys formulate those as the states of the blanket, which I think is fine. Although I have a question, I guess, as to what that formalization adds to a picture, as I just described it, of course graining, of population coding, of different regions in a hierarchy. So that's one question. And then I'm going to channel Louise for a minute and just take issue, I guess, with the idea of there being a single top layer of the hierarchy that doesn't get any context from anywhere else. And that makes me a little uneasy. It feels like the real sort of Cartesian theater, or the ultimate ghost in the machine sort of scenario. And it feels like there could be, while you could have a hierarchy, it doesn't have to be a strictly pyramidal hierarchy. You could have a kind of a more square hierarchy that have levels, but you've still got some lateral context at the top. Multiple sort of regions that have their own Markov blankets, if you will, but they're all at an equivalent level of the hierarchy almost. I'm wondering what you think of that. And the other.
Well, I completely endorse the latter part of what you were saying, 100%. So, we depicted this as a hierarchy, but it's definitely an oversimplification. Probably a heterarchy is a better way of thinking about this. I would think that, there would still be something like a topmost set of blankets, and then they might be mutually constraining to each other. But there's probably a layer at which you're not ascending and further coarse graining in the same way that you were doing to get to the top. Although, I need to think about this a little bit. It's a very interesting point that you raise. If we're going really radical heterarchy, then this is like a circle more than anything. But I do think that if you're thinking about the layers as successively coarse graining each other, then there is probably something like a top. I'll poke Karl in a minute. We have the man himself on the call, so I'm curious what he thinks. In terms of the utility of the free energy principle, the FEP is a canonical modeling technique for dynamical systems. So there are a bunch of, I keep saying on Twitter, as you know, oh, this is also the free energy principle, and this is also the free energy principle. I think Jules Hedges nailed it last year. He said, I suspect, so Jules Hedges is a category theorist from Strathclyde, one of the people whose mathematical chops I respect the most in the whole world. And he says, I'm beginning to suspect that the free energy principle is both true in the sense that it's the right way to do it, and far more boring than people have been discussing. So, I think the free energy principle is like maximum entropy. It's like least action. It's one of these principles that may or may not be useful to describe the dynamics of a system. It'll be useful in particular to describe systems that look as if they had beliefs about the environment. So, you were saying that the Markov blanket picture is pretty widely accepted, this whole sparsity thing. What we're kind of saying in the epistemology of the free energy principle is everything is like this. I am like this to you right now. You only have access to my sensory motor interface, or at least direct access, right? And this is true for rocks, for brains, etc. If you're doing neurophysiology, you are limited to a certain scale of interventions to learn about the brain. Sure, you could break.
I mean, in one sense, Maxwell, sorry to interrupt. I think that's part of it's part of why sometimes people have a reaction that's a bit like a head scratching reaction, in the sense that if the FEP is just as much about, or just as applicable to a rock as it is to a brain, then what do we get as neuroscientists from applying it in the brain? I guess that would be the challenge, right? It's like, if it explains everything, what do we get from it that's in any way sort of specially useful?
Well, I think there are a number of really key things that you get out of it. One is, and I'm open to being challenged on this, but I think it really is the canonical way to tie information entropy and thermodynamic entropy together. So to my knowledge, there is no other approach that gives you a set of equations that constrains the dynamics of a system, both on the information theoretic side and on the thermodynamic side, right? So, I mean, the FEP says if you maximize the entropy of your beliefs, over time, you're going to keep the thermodynamic entropy of your system at bay. And that's I think really key and unique to the approach. I would submit to you. And the more living or cognitive a system looks, the more you're going to get out of that particular formalization. I would submit. Although, if I may, I would like to poke Karl and get his take on this. If you're there, Karl.
Yeah, I'm here for poking. Yes, great presentation, by the way, and great question. Yes, the first question about the heterarchy, I think that's absolutely right. So in a very deflationary way, you can just take any adjacency matrix and identify one or more minimal or irreducible Markov blankets. And I don't think there's any particular commitment to there just being one. You could have a split brain preparation with two, and they will be very distributed. I mean, the one thing that we do know under this particular hypothesis is that it must include the cells of origin of ascending neuromodulatory systems. So it's not, just the hippocampus. It's a distributed system that is characterized by a set of connections, which means that there is no way of further subdividing it, and it's likely to include quite a large part of neuroanatomy. In principle, you could measure it if you actually had a connectome with sufficient resolution. Then, in principle, you could actually identify it just by starting with the cells of origin of, say, the classical neuromodulator systems and working backwards. Clearly, we don't have that information, but in principle, you could do that. In relation to the second question about why would you want to deploy the free energy principle or apply, a better way of describing it, to neuroscience, I think that in addition to Maxwell's answer, I think it's important to appreciate that there are different kinds of Markov blankets leading to different kinds of dynamics and mechanics, and things that do planning and can be described as agents have a very special form of sparsity that would make it a different kind of thing from a stone. And interestingly, if you look at the various limiting cases of different kinds of Markov blankets, the things that have very precise internal dynamics and a particular lack of connectivity or influence from the active states to the internal states are those things that look as if they are planning. And I think that's the special kind of dynamics that you'd look to try and look at for the manifestation of that empirically in neuroscience. You wouldn't be looking for that kind of dynamics in a stone, for example.
That's thanks so much.
I pulled up something to add to Karl's response. We've put out a paper recently on particular kinds or kinds of particles. And the idea there is that, as Karl said, the sparsity structure of the blanket is important. So there are inert particles that have no active states. So, you kick a rock, its structure changes, but unless it's radioactive, the rock is not going to then affect you back. There are active particles that do have active states. And then, what we're trying to suggest here is that, the kind of particles that are conscious are strange in the sense that they don't have a direct access to the actions that they're generating. In particular, this apex structure has to go through other layers in order to kind of apperceive itself. And this leads directly to things like planning as inference, if you unpack it. I will say generally, there's a philosophy of nature that falls out of the free energy principle that dovetails really nicely with some of the work that Terence Deacon did in the book Incomplete Nature. The fundamental thesis is that Aristotle is wrong, right? The whole is, as we were saying, Kevin, actually on Twitter this week, the whole is less than the sum of its parts, right? That's how wholes and emergence work, right? If you have an engine, the engine functions because you have effectively removed degrees of freedom to all of the parts of the engine in very specific ways. Like you have caused, for example, the pistons to move along 1 degree of freedom only. And the best way to wreck your engine is to start introducing degrees of freedoms into the pistons and stuff, right? If you want your engine to rip itself apart, that's the best way to do it. And so a thing is defined by what it is not, in some kind of paradoxical, perhaps, sense. And I think that's really like a core takeaway here. Like things emerge through sparseness. If everything is connected to everything else, then there are no things.
Right. Yeah. So let me, before I take more questions, let me just ask a little bit more so that we can get at this key aspect of the way that you formulated the whole framework. It has a couple of elements for us that are interested in how the brain is organized that I think is both a question and kind of suggestions as how you're going to interface with the group that is, with the community that is more into the brain organization, as opposed to more consciousness at a level slightly different. So I guess one of the things that is it comes back is Kevin's question about the organization, the whole organization that you were implicitly or explicitly adhering to, which is in one sense you have a description that is very hierarchical and very well organized, and on the other hand, Karl was saying that you could basically tweak that in almost to any kind of architecture, as long as not everything connects to everything, then you have some adjacency matrix or some overall connectivity scheme, and it should be fine. I guess it might be a little bit of a detail for you, but I think it would be important, because by subscribing to at least diagrams that are so hierarchical, you're implicitly suggesting that it is that way, and you're not even kind of putting like in the kind of scheme that Fuster and others, when they were proposing that the PFC is at the top of the hierarchy, they're in their schemes from the 80s and famous figures, these things are connecting quite a bit, like exactly like Kevin was saying, and yours is even more hierarchical. So I guess what I'm trying to say is that it would be interesting to see whether you want to have a formulation that is completely agnostic to how the brain is organized. But if that's the case, then I would suggest coming up with figures that don't tie it so much to one view or another, how distributed, how hierarchical, how parallel distributed the system is, how whatever architecture that you have in mind. And the other thing I think is very important for you to contextualize and think about is how the field is going to, and this is, I think, is going to come from everywhere, is this notion that there is a top, right? Because we've been fighting with this top forever in every single respect in neuroscience, in AI, and everything that we try to make autonomous, because at some point we have to, the top can't be intelligent or powerful by itself, right? Because otherwise we just have to attribute it some power that we can't explain. So it's somehow, we can't have a controller that by fiat controls everything magically. So you kind of have to explain why the top is the top as you're supposing. And the way Karl was formulating is that this top could be huge, right? So it seems very different from the top that you're putting the hippocampus, and another top that was like, oh, it's all these things, and the midbrain and PAG, and then maybe prefrontal cortex contributes too, and then default, so where does this top end? I think is going to be important for you pragmatically to decide, because the scheme is very incredibly elegant, but I think that for some of us that want to ground it or try to understand it through the lens of neuroscience, we're always going to be trying to see, how does this translate to how I think about the brain, and how I think about the brain, how I think about consciousness in terms of mapping the mappings with the brain, right? So what kinds of states are felt in certain ways, or you have a midbrain lesion and you lights are out, and one in the thalamus changes your state of awakeness and anesthesia during surgery, and so on and so forth.
So
I don't know, it was very long, but I wonder if you have some reactions to that.
That was great. I do actually. I want to agree with almost everything you said. Yes, we should definitely move towards depictions of hierarchies and kind of the complex interminglings of all that stuff. I would say that there is, this is sort of brain physics in some sense. And so there is a kind of deliberate effort at perhaps oversimplification. We've got some work coming out that, is moving in the direction of biophysical realism. So look, consider the Markov blanket. Obviously, I don't have a perfect blanket. I don't know about all of you, but I had coffee this morning. I used the bathroom at least once, right? So there is this material turnover that is evinced. And so, Markov blankets are always bound to be approximate. Dalton Shaktivadivel, who's on this call, has done some amazing work over the last 2 or 3 years on what he calls weak, or what I call fuzzy blankets. So you can recover, it turns out, almost all of this machinery while still admitting that the blankets are not perfectly sealed off to the world. So, I mean, in some sense, the same way that a perfect Markov blanket is an approximation for something that's actually fuzzier and that we're moving into now, I want to, take on board your suggestion, and we can probably fuzzify this construction as well. I would suggest, though, that there is something like neo-Cartesianism here, and I've been calling this an explicitly neo-Cartesian view. I think this kind of view gives us a way of naturalizing the homunculus in some sense, not as like some kind of silly observer observing the observer kind of thing, but rather this right-only layer. It really might be able to account for the absential or intentional phenomena that like Deakin and the phenomenologists go on about. Like the fact that you have a layer of processing that is strictly about other layers might explain why it appears as if there's like a privileged layer that we classically thought of as a homunculus. So actually, one of the things I'm excited about here is that we might be able to experimentally probe into whether it makes sense to talk about a homunculus. And then it moves from being this kind of, infinite regress, problematic philosophical thing to something that we can assess whether or not it exists.
Yeah, I think it's really a key one of the key elements, right, of your framework is really that it has this level that you even write it as, you even indicated it as right only, right? It's like, really, it's a really strong position. And so I think that obviously, I think that you need to develop it in a way that takes people's reactions. Like we're going to have some kind of knee-jerk reaction at first. It's okay, let's entertain it because of, and then you kind of elaborate because it's really a challenging one. But I think admitting from the get-go that is almost like, I wouldn't say I necessarily want to call it neo-Cartesian, but it does have that element, right? Depending on how you conceptualize that top level or higher level, I think it does get rather close to some notions that some would call rather Cartesian, and has shaped the debate so much, right? In terms of Cartesian, but for decades, right? I mean, people are being...
Well, frankly, I would take that as a badge of honor. I think Descartes is one of the most maligned figures in philosophy. In the 1800s, Descartes was responsible. He was the instigator of the soulless clockwork universe, the ultimate mechanist that just sought to explain the mind in terms of, mechanics and stuff. Fast forward 100 years, Descartes is, the evil inventor of substance dualism, and so actually, if you read Descartes, Merleau-Ponty died reading Descartes. Merleau-Ponty had a stroke while reading Le Monde.
No, I didn't know that.
Well, so it's an interesting thing to note, and this is how I feel about it. This is a metaphor for my own philosophical progress, actually, as a student of phenomenology and philosophy. I feel like I was trained in the late 2000 noughts, early 2010s as an E-theorist, and then rediscovered Descartes and physics and mathematics in the course of it. So I kind of feel like, I'm trying to embody within my work this kind of return to Descartes, which isn't, by the way, Fodor is silly Descartes, right? Like, but there is.
No, understood.
There is
No, of course, it's understood. I think outlining that it sets the stage, right, for people to know exactly the positioning, and it's like, is it implicit? It might as well be direct and explicit and indicate. Yeah. But let me take some questions. Go ahead.
Could I just please
Yeah, of
poke?
course.
I'd like to poke at Adam Safron, actually. Adam, you're on the call. Adam and I have been, thinking about neo-Cartesianism for the better part of the last decade together. And I wouldn't want to steal Adam's thunder. I think he's probably the main defender in the literature of this. Do you have a few words? I noticed you chatted in the chat, Adam. Do you want to say a few words?
Hello.
Hey there.
Can you hear me?
I love the look.
Yeah, we can hear you. Yeah, we can hear.
Thanks.
We can see you too, man.
Oh, that's too bad. It's hot out here and sunny. Yeah, it's possible that I'm taking it too far with the Cartesianism, and that what we're arriving at now is a more like reasonable ecumenical position. But I've been talking with Maxwell for a while about kind of a sense that, like, in a way, it's part of Dan Dennett's wonderful, but also maybe somewhat mixed legacy of basically making Cartesian intuitions almost taboo to think about. But if some of those are actually important design principles for controlling cybernetic systems like us, things like creating centralized control structures, not necessarily because of some sort of like crypto soul intuition and crypto religion, which isn't necessarily a bad prior, but because that actually might be a very efficient way of setting up a control architecture for an embodied agent. So the basic idea is there's some questions about if we try to neither to assume something that's going to directly correspond to folk psychology, but not making that taboo either, to look at something that may be a lot like what the folk have in mind as actually in a way resembling what the abstract computation realization might be. And so in this case, we don't have to go this far, but one thing I've considered is in deep learning, you oftentimes get better performance for modeling physical systems if you take latent spaces and you give them a kind of geometric structuring that resembles the thing that they're representing. For some, it can be many orders of magnitude more efficient. And so this idea of creating a kind of like homomorphism between the physical, the implementation, and it's the algorithms being so realized, it's not necessarily a naive thing to think about, and maybe could be part of the solution for understanding the nature of neural computation, contributing to things even like the generation of experience. I don't know if that helped or hurt, but
no, I think that helps. I think that's good. I think that linking it up like that and describing it, I think it's important, because I think that otherwise we're going to just repeat all these debates that we've had for decades. And I think that having a position in from the outset, describing it that way, I think it's important. Yeah. But let me get, thanks, Adam.
Yeah.
Let me get Andrew and Ben to ask their questions. I apologize for taking so long, but Andrew, please go ahead.
Thanks so much, and no problem at all. I'm Andrew. I'm not a neuroscience, so I want to poke a little bit at your definition of holography. It looked like you were providing one that you said, "I'm not using this one," is what I understood you to be doing. But I think what I heard when you were saying holography is that all the information available of systems within a Markov blanket can only be represented on the Markov blanket, right? So if I'm outside, all I can see of the internal system has to be presented on the blanket itself, and I can't see inside. Is that a sort of correct way of understanding what you mean by holography?
I mean it in the sense of the holographic principle, which is this principle from black hole thermodynamics in particular, or at least that's the context of discovery, which says that from the perspective of an external observer, the only degrees of freedom that are accessible, that exist within some bulk, have to be encoded on the boundary. We actually, so Chris Fields, I think, is here, and is he still here? I saw him pop in. He is the relevant quantum information theorist. So I was hoping that he could sanity check me, but that is the idea. Well, just to clarify, one of the things that I wanted to suggest is that the second sense of holography, which has to do with the creation of holograms and interacting wavefronts, there might be a connection there. So again, this is Adam's work, Adam who just spoke. Adam has this awesome concept of self-organizing harmonic modes. This dovetails a lot with the work of George Northoff, who's based in Germany, I believe, Germany and Canada. He's done some very interesting work suggesting that frequency bands in the brain have to be organized in terms of harmonic resonance structures. Otherwise, you don't get full-on consciousness. So one of the, so I'm not a neuroscientist by training. I am probably doing a poor job at recapitulating his findings, but basically in anesthetics, in patients who are under anesthesia rather, and in people who are sleeping and who are not dreaming, these frequency bands don't resonate harmonically. They're kind of off. They're not tracking each other. Whereas in conscious systems, these frequency bands tend to align very well and to create these kind of overarching resonance structures. So the hypothesis is that if the first use of the hologram theoretic rendition of Markov blankets makes sense, then it might be the case that you also get this kind of wavefront interacting, like dynamic stuff going on, and then you could appeal to holography in the more kind of hologram of Tupac sense, if that makes any sense.
Yeah, that makes a lot of sense, because I'm imagining a Markov blanket would, one of them would be the boundary of a single individual, or a group of people could also have a Markov blanket around it, and
That's
all
right.
I can see of another. The only information I have available about another individual is encoded on their Markov blanket, right? It's
Exactly.
Their expression, their behavior, the things like that. And so I would need a system to predict and minimize surprise about that other Markov blanket. And all I have available is surface information. And therefore, I would need a consciousness. I would need an internal model that was equally complex to the system I was trying to predict, and I guess, or the social group. And I don't know if I'm way off base here, but it imagines.
No, all of that I
right.
endorse. This is precisely.
And so consciousness would be a sort of a how do I generate a model about objects as complex as me?
Precisely.
And they're all around, and not only that, but a socially bounded. So it's not an individual doing that, but there's even layers out into social, civic, society, global, that I need systems inside me that can generate predictive and minimize free energy. And that would, I guess, suggest to me that's what consciousness sort of is, that thing that is trying to
I'm
predict.
so happy you're saying this. So one thing I didn't think I'd get to today, but that in some sense, your intervention is inviting me to clarify, is that, so we, if you start with the Markov blanket of the organism, what we did in this paper is look inside and look at the nested structure of the internal states. But I said there are 3 papers that we're preparing. One is the one that you've all read for this. The other is a paper on the mumness, the minimal unifying model status of the model that we just presented. And then the last paper, which is more tentative, is about looking outwards with the same structure. So out to the encompassing social systems. And in some sense, kind of, this is sort of the Hegelian turn of our work, in some sense, kind of like the necessity of recognition of others and all of that kind of like, recursive recognition of agency stuff. But that's still very tentative, and we're slowly moving in that direction. But I agree with everything you said, Andrew. That was great.
Oh, cool. Thanks so much.
Okay, great. Ben, are you there? Yeah.
Hey, Ben. Nice to see you.
Hey, Maxwell. Great talk.
Thank
So
you.
I want to follow up on the Cartesianism discussion here. And you mentioned, we're trying to naturalize the homunculus. I think in a way, where it's providing, maybe mechanics of the updating of the homunculus, but I don't really see how it naturalizes in the sense of getting past the one fundamental criticism that was always the problem with that view is who's watching the screens. If it's screens within screens, even if you say it's a network of screens, it seems that you never get to subjectivity, and you're always going to have to posit that at some lowest level, the system's modeling its environment, whatever, there's a screen there, but then you still have to put an experiencer into that system, and then that just becomes yet another screen. So I'm curious. Yeah, go ahead.
Yeah, great question. So what we're suggesting is not really that there's an observer of the screens. It's more that there is a screen whose function is to observe the rest of the system. So yeah, and then you don't get this infinite regress problem, because precisely what we're saying is the screen can't observe itself. Like this top layer, it has to infer its own, in some sense, infer itself into existence by, kind of through the consequences of its covert action on the other layers and through the consequences of its overt action in the world. So precisely, we're trying to dissolve that. As to, I don't know, like naturalizing the homunculus was an intentionally inflammatory way of putting what we're doing. I don't really know if naturalizing makes sense on its own. I'm a proponent of phenomenologizing nature as much as I am of naturalizing phenomenology. So I think it goes both ways. But here specifically, like we are outlining like a functional architecture. And what we're trying to do is, in some sense, implement Thomas Metzinger's notion of opacity, right? So that there is a layer. There's the hypothesis, right? We may be wrong about this, but we think that there is a layer, the top layer of these hierarchies, and what they're doing, their action is to render the rest of the system opaque, so or accessible to itself. But I mean, great question, and I hope that helps a little bit. I don't pretend to have resolved.
Yeah, I mean, just to push on it a little bit. I think saying there's a screen that observes is a convenient way to try to get around it, but I don't think that does, because screens don't observe, right? Things project on the screen, and then there has to be something on the other side to observe. Even though we're talking in metaphors, I think there's a real sense in which if you have that top layer and it's just a screen, you're left without a subjectivity. And maybe that's okay. I mean, some people are totally fine to say, like, we don't care about the idea of there being a subjectivity or an experiencer in here. We just want to describe the system. But yeah, I don't know. Do you care if it gets to subjectivity at some point? And
well, I don't think it's sufficient on its own for something robust like subjectivity. There are other, so in the original 24,000 word monstrosity that was this paper, we engaged with so a few other theories that we think are relevant, in particular, the projective consciousness model, which tries to account for the kind of 0 pointness. And that had, there was just no room in the paper for it. But I think if you stack this kind of structure, so by the way, I'm using like metaphorical language. What the screens do is successively coarse grain the screens after, and you read and write onto them. So there's no real sense in which the screen is observing anything, right? That's sort of like, you can borrow, or you can take it, observe in the quantum information theoretic sense of an observation is just a physical interaction, right? So like, but I guess what I'm saying is like the screen is not self-observing, so you don't get this infinite regress problem. Its function is just to read and write onto bottom layers, and you get this, it's in this kind of circle of updating that something like subjectivity emerges. But this is a great question, and I should probably think harder about that.
Thanks.
All right, Anna.
Hey, how are you?
I'm great. Good to see you.
Good to see you. Yeah, so my obsession with basically asking this question from a developmental perspective, right?
Yeah.
Yeah.
Good obsession.
Yeah, it's kind of like I'm obsessed with that because, well, I'm saying it's like, okay, so whether people agree or disagree with predictive processing is like that's a big debate, and but I think there's this idea that whatever we kind of like experience or perceive right now is influenced what we perceived before. I think that's kind of like fairly uncontroversial. So it's kind of like there. So this means it's really, really critical to go back to the first type of like observation or perception or processing that we have. I know we still need to find the correct word for that. I mean, the right word, because it's like, I think one of the problems we have in the discussion that I just saw is that we can't help but to use a conceptual toolbox and a language that comes from something that we observe like adults, right? Like there is language that we read and kind of like, and there's a hierarchy, there is a bottom, there is a top, and we try to, navigate through them. But maybe what we have right now is really a limit of kind of like mapping the phenomena with the concepts that we have inherited, right? So we try to, map something that gets even more complex and complicated, but with some tools that actually they were designed to map a certain mechanistic type of like things, right, in a certain way. And when we apply this to life, like a living system, like the brain, maybe that's kind of like part of the problem comes from, as you said, it's like people will push you, they'll say like, well, there is no observer. What do you mean by observer? Observer, just say homunculus or a screen. It's like you need to read and write. So, but I think that's kind of like contingent, and that's just like a terminology problem, right? My question for you is about the, I think what was kind of like related with what Andrew said a bit before, is like the fact that we actually, as biological self-organizing system, we are never alone. Actually, literally never alone, right? So this means that we emerge already within another biological system. So like we need to basically organize ourselves models and Markov blankets in function and kind of like negotiation with other Markov blankets, right? But in a very strong embodied way, right? So how does your theory fits into this like radical idea of like the fact that it's like at the beginning that we don't have just like one Markov blanket, we necessarily have at least two. And
so
actually,
I love this question. This is awesome. Well, I would say that as currently written, the paper doesn't address this, unfortunately. You're right to point to a hole here. This is what I was trying to suggest was the direction of travel for the third paper. I mean, the one way to kind of just talk through the idea here is passing down of Markov blankets, right? I think you've used this expression before. So, when one gives birth, one in some sense, constitutes another thing, and either is a kind of shared boundary there. I think it's probably the case that just as there's a kind of passing of the Markov blanket down generations through reproduction, there's probably a developed apex structure through social interaction, and in particular through others recognizing you as a moral or like cognitive subject. So I entirely agree, and this is something that we're hoping to move in the direction of. I apologize for this not being in the current rendition of the paper, but you really put your finger on where I want to move with this. So thank you.
Okay, great. Sander?
Hey, Maxwell, thank you
Hello.
for the talk. Hello, nice to
Pleasure.
meet you.
Likewise.
Yeah, I have a question. So I read the paper, and I have this good old question about, I guess, modeling versus, or whether it's just I wasn't sure whether you're giving a theory of consciousness or whether it's really just a modeling tool. And when I read the paper, I kept being confused between those two things. And because, for example, in your explanations, you do use a lot of words that are about causality, right? For example, you have this stack of layers, and the top layer writes into the lower layers, and so forth. So so what is it? Is it a modeling tool, or is it also a theory of consciousness in the sense that this is what the causal requirements of consciousness actually are?
Great question. So I think there are two levels to the answer. The first is just the free energy principle per se. And the second is this inner screen model of consciousness that we've developed. So the free energy principle is not a theory, right? It's a principle. It does what it says on the tin. You use it as a heuristic, and what you obtained from it are theories. So when you write down a specific generative model, what you're doing is writing down something that could be subjected to experimental verification. So what I think this is a theory, and I've been actually discussing some of the possible predictions that we would make based on this theory, the existence of, like, you know, a homunculus screen, if you'll allow me the enormous scare quotes, and so on. So yeah, I would think that this is consistent in application of the free energy to generate an empirically testable theory. So, I mean, taking one step back, we can distinguish empirical theories from mathematical theories. So the word theory, as you know, is used in like 15 different ways in the literature, right? So by theory, you can mean, a mathematician by a theory means a mathematical structure. When he says this theory, you know, when a mathematician, they do this or that, what they're talking about is a formal structure. That's different from the use of the term in the empirical sciences to mean, you know, an interconnected set of statements and formalisms that may or may not map onto the world in specific ways. So within mathematical theories, what we have done, and we know what I was talking about at the beginning of the talk, is to distinguish dynamics, mechanics, and principles. So I guess the whole kind of flow of the argument is there's this free energy principle that we can use. In this paper, we use it to model the nested layered structure of the brain in the hopes that it will generate a theory of consciousness. And in applying the free energy principle, you get these kind of structures like that I was sharing a bit earlier, like this. Where you know, you're sort of getting closer. So this is a cartoon version. We rewrote this for the Journal of Consciousness Studies, and they basically told us that we were not allowed to use equations. So yeah, we wrote this informally, but you can think of this as a model sketch. And I would think of this as a mechanical model, so a mechanics that we are using to explain some dynamics, and that hopefully maps onto the empirical data. So the FEP is not a theory, but this, I think, is a theory. That's my take anyway.
All right, great. Can I ask a follow-up question? Is that okay, Luis?
Of course.
Yeah.
Okay, can you keep sharing the screen? I had a question about what you just shared.
Sure. Go for it.
Yeah, so one thought I had here, okay, so the hippocampus is at the top of the neural hierarchy, and then, but is the idea that the lower level Markov blankets are in a way parts of the hippocampus, like let's say the canonical circuits or the neurons that make up the hippocampus, or is this more a scheme where there is an interaction within with other brain areas?
It's the latter. It would be an interaction story. And if we were, you know, like we depicted one top, you'll see it's even in scare quotes. We're cognizant that there's not just one top, but there would probably be several such tops, like that are equally top,
right,
in some
right.
sense. Yeah.
I think that's an important distinction because in the paper itself, it's often about having this nested structure where it's almost about levels of scale. You have one system, or let's say one network, right? And you can say, well, this network is composed of lower level Markov blankets, and those are modeled in terms of the neurons that make it up. But it's a different thing to say this brain region feeds into that brain region. Then we're not talking about levels of scale, then we're actually talking about different physical entities that are connected. And I think that's
absolutely
major difference philosophically.
We should probably clarify that if that is not clarified. In the paper itself, I think what we tried to do was we first discussed the ascending and descending scales of self-organization. And then in our discussion, we moved to predictive coding. And I think at least using this figure was meant to suggest that we're talking about one scale specifically, the scale of the brain and its activity, and it has this layered structure. But in principle, if you ascended scales and then considered brain networks or went down to like cortical microcircuits, you would probably, we think, have the same kind of sparse interaction structure. But it does make the nested screen story more complex in the sense that it's not just nested layers within a given scale, but you have nested scales of such screens.
All right, that's great. Thank you.
You're welcome. At the Confino Fridays, what we usually do is try to give the last minute or two to Karl so that he can kind of wrap up and give us some feedback. Luis, are you happy if I poke Karl one last time?
Yeah, you want to wrap it up? I mean, I had one more question. Can I ask you one more question before?
Yeah, of course, absolutely.
So I guess my question is a little bit following the Sanders point a little bit in terms of space, but shifting to the temporal domain. Like, so how do you view, how does the general framework in this paper of consciousness paper or more generally, how do you view the possibility that some of these coalitions or these levels have their own spatial temporal dynamics, in the sense that, for instance, let's say that there are some kind of interactions between, so supposing instead of having a canonical picture of the brain with several networks that are interacting and they have their interactions, these networks themselves are dynamic objects that coalesce and have their own dynamics and fuzzy boundaries and essentially these more complex spatial temporal objects. So that's,
I love that.
That's not something problematic. That's just something that it's absorbed and it doesn't, there's nothing about space and time that require any rigidity, right? So, because you can just come up with any flexibility or rigidity that we find empirically in the brain, presumably, right?
Absolutely. So I'm sure you're familiar with Mike Anderson's notion of a talon, a transiently assembled local neural Ben, what does it stand for? Transiently assembled local neural,
transiently active local neuronal substrate, I think, or subsystem.
Okay, so something like that. We did work about 3 years ago now on transient Markov blankets.
I see.
So actually Dalton should be putting out a few papers later this year. The cool thing about the current formulation is that the Markov blankets themselves can be random variables, right? So like you can think of like the set of all possible states, and then the blanket is sort of shifting around. And we actually have some computational work. Let me just link the paper in the chat. I'm sorry for being so self-indulgent here. Give me 1 second. So this is actually one of my lesser known simulation papers, and it's a little bit sad to me because I think it's some of the cooler simulation results that we've done. So in this paper, we simulate a bunch of artificial neurons with their own little Markov blankets, and they basically form higher level Markov blankets in a way that tracks the features of stimuli that are presented to the ensemble, which I think is pretty exciting and hopefully speaks to what you're talking about now. So like, very literally, like we present a stimulus that changes over time, and the individual neurons change Markov blanket membership at the higher scale in a way that tracks the time course of the stimulus presentation, which is, I think, really cool. And obviously this is just a toy model, but I think it gives us a grip to kind of think about the way that, these so-called modules or brain networks are actually continuously reconfiguring in such a way that they adaptively are tracking stimulus features. So I think getting more realistic about that stuff is important, but our view definitely accommodates that.
Yeah, and that's fascinating, because I think that, I mean, obviously you already have a lot of directions that you're tackling, but this direction seems quite important in terms of accommodating brain dynamics, right? And yeah, great.
Couldn't agree more. Thank you. And now I poke Karl for one last time.
Well, it's
If
very
he's still
nice.
here.
I'm
There
not
you go.
sure I deserve to close it. That was a fascinating conversation, and Lou, thank you so much for putting this together. I feel a bit out of my depth, Maxwell. Normally, I feel more confident, but this has been such a high-end philosophical discussion, tainted with dynamics and to a certain extent neuroscience, that I will defer to a lot of the observations as intending everything that should be concluded. I think most of the conversations were brought to conclusion. The two outstanding ones actually were covered in the last exchange, and I noticed in the chat that Kevin was noting that there was a link between the temporal scales and the levels that we've been talking about. And I think that was brought to the fore by the final exchange and the final question. I think that's quite fundamental. And just one nod to our naughtiness in promulgating this sort of subsumption hierarchy, a la hierarchical predictive coding, in the 1990s. One way of getting away from that is to not use the word layers and use the word levels and scales. And I think that's much easier, I think, to associate with things like centrifugal hierarchies of Marcel Mesulam, and to a certain extent sort of Fuster's construction, but also allows you more gracefully to talk about heterarchies, which are probably more talking about things. So I'm pretty sure if we go to the paper, we'll find levels everywhere. I think that should be, it's just when you're putting levels in graphics, it's just much easier to do a stack of layers using PowerPoint.
Absolutely.
Carefully craft a proper hierarchy, but perhaps more attention should be paid to that. So the notion of different levels, I think, is absolutely and intimately tied to a separation of temporal timescales that was implicit in the last discussion, and indeed in some of Kevin's observations, and nicely illustrated, Maxwell, by the paper you just showed us. It has a deep history. Even in my academic journey, hierarchy of temporal scales in the brain has been a sort of fundamental spatiotemporal architectural principle that is emergent from this kind of hierarchical generative model. I think that's absolutely crucial, and it sort of I think speaks to what is being observed, if you want to use the observed word, and the scale, the kinds of scales and the kind of actions that are deployed. They can only be very, very slow when we're talking about irreducible Markov blankets or levels or scales of dynamics, which tells you something quite important. You're freed from the instant, in the spirit. I can't remember what your favorite philosopher is, but I always recourse to Jerry Edelman's remembered present here, or some kind of temporal thickness in a more philosophical. That's baked into this when one applies the free energy principle to hierarchical generative models. So I felt that was a really important thing, especially talking to people who are fluent in neuronal dynamics. The other thing I thought was probably needed more discussion was this important notion of, dynamically speaking, a generalized synchronization or synchronization of chaos between Markov blankets who have got used to being together in some way. That is another emergent property of this variation, these variational principles of coupling of sparsely coupled systems, where you can only look at the when another person is only manifest in terms of their Markov blanket to which you have access, but you still have to synchronize with them. And how that leads to a sense of self in the spirit of, in order to do the synchronization, you might test the hypothesis that there is another, and if the other is a thing, perhaps I'm a thing like the other, and then you get towards a minimal or a sense of selfhood, which was not, I think, the sense of selfhood was not, or the sense of self was not really the target of what you were talking about, Maxwell. I think you were talking about slightly sort of first step, which is the inactive aspect of the kind of consciousness, or possibly experience, but possibly that's going a bit too far. But just getting into the game, this notion that there is internal action and mental action that has this dynamical structure, this hierarchical structure. So it may be worthwhile just qualifying that the MUM as articulated very gracefully is not going as far as possibly even qualitative experience. It's just foregrounding action. What is acting? Well, everything's acting up and everything else, but what is special that we might associate with the kind of actions or inactive aspects that makes us into agents? And we are assuming to be conscious, we have to have some kind of agency. So I thought that would be a fruitful discussion point for when you present paper number 3, which I haven't yet seen. So that's how I will conclude. I really enjoyed listening to that. Thank you very much for inviting me.
Thank you, Karl. That was great. And thank you, Luis, for inviting us. This has been fabulous.
Great fun. Yeah, thank you so much. Okay, everyone. Hope you enjoyed it. Bye.
Goodbye.
Bye.
Genuinely a pleasure. Take care.
Bye.